Good day everyone, our topic for today is all about concentric circles in nature. So what is concentric circle? Concentric circle are the circle that are different sizes but they share the same center. They circle each other, growing out and get bigger and bigger. They're not just in ponds, on the tree stumps, they're just on kitchen. Examples of concentric circles can be found in nature. The ripples made when a pebble is dropped in the water is our concentric circle. The rings on the inside of the tree trunks are also concentric circle. Geometric properties. Annulus. Annulus is a two-dimensional flat figure shape in circular form which is constructed by two concentric circles. The region of the area formed in between two concentric circles is called annulus. Here's the annulus equation formula. Area of annulus is equal to pi big radius squared minus small radius squared. So here's the example. What is the area of annulus of two concentric circles given and the circles have a radius 2 and 5. So here's the formula in the solution of annulus. So substitute lang ang 5 and 2. So 5 squared is equal to 25 and 2 squared is equal to 4. So 25 minus 4 is equal to 21. So 21 pi is equal to 65.95. So yeah. Tessellation. So what is tessellation? Tesselation is created when a shape is repeated over and over again, covering a plane without any gaps or overlaps, or is a pattern created with identical shape which fit together with no gaps. In another word, tessellation is a tiling. Tiling, when you fit individual tiles together with no gaps or overlaps to fill a flat space like ceiling, wall, or floor, you have a tiling. The word tessera in Latin means a small stone cube. Here's the some types of tessellation. Translation tessellation is a tessellation in which the shape repeats by moving or sliding. So here's the picture of translation tessellation. So the second tessellation is the rotation tessellation, a tessellation in which the shape repeats by rotating or turning. So here's the example of rotation tessellation. The third one is called reflection tessellation, a tessellation in which the shape repeats by reflecting or flipping. Here is the some example of tessellation. Tessellation occurs when a polygon is repeated in a plane without gaps or overlaps. So, unsuccessful tessellation, it occurs when a polygon is repeated in a plane or gaps or overlaps are formed. Those are the example of tessellation and unsuccessful tessellation. Transformation and tessellation. Transformation occurs when a polygon is transformed resulting in change of its position, shape, or size. This can be done with a flip, turn, or slide of a polygon. This is the type of transformation: the line symmetry, the rotation symmetry, and the translation. The line symmetry is the shape are flipped. It occurs when a figure is reflected over a line and it appears unchanged. Rotation symmetry is the shape is turned. It occurs when a figure is rotated around a point and it appears unchanged. Translation is the shape is slid. It occurs when a figure is moved along a line without turning or changing its size and shape. So this is the examples of the rotation, symmetry, and the translation. This is the group through video presentation and the answers of guide questions.
Hi everyone, good morning. I'm Gay and Donan. I will answer today the 3 questions. So the first question is, what main concept is fully discussed on your assigned video? So, the video is all about tessellation. This created or what we call tiling. Okay? So, can be arranged to fill a plane without any gaps to fit together. And the second question is, what is about this concept? cite few more real-world cases or examples that won't show the concept. So my answer is examples are floor tile or tile floor and chessboard and fabric pattern. Alright, examples. The floor tile, you must arrange it properly and fit together to have a better results. And the last question is, what are your insights about these mathematical truths or say certainties? So, in mathematics, a tessellation or tiling is when we cover a surface with a pattern of flat shapes so that no overlaps happen. And that's all. Thank you.
Good day, sir. So today we will discuss the three guide question of concentric circles in nature. Question number 1. What math concept is fully discussed on your assigned video? This video is all about of tesselation patterns. What is about this concept? Cite few more real-world cases or example that could show the concept. Geometry formally defines a tessellation as an arrangement of repeating shapes, which leave no space or overlap between its pieces. There are usually no gaps or overlaps in patterns or octagons and squares. They fit perfectly together, much like pieces of jigsaw puzzle. Not all shapes, however, can fit snugly together. Circles, for instance, would not create a tessellation by themselves because any arrangement of circles would leave gaps or overlaps. Despite the limitation on the types of shape that can form these intergoing patterns, there are many varieties of tessellations. Patterns using only a regular polygons to completely cover a surface are called regular tessellations. On the other hand, use a combination of different regular polygons such as the patterns above, and you can typically see example of these patterns in the tilework of bathroom and kitchen floors. Tessellation made from regular polygons, equilateral, triangles, squares, and hexagons are usually referred to as tiling. However, tessellations can be made from many regular shapes as well. For example, the fish and chicks animation below show how can alter a square to create on irregular shapes the tessellation a surface.
Good day everyone, my name is John Paul Panis from section Golf, and this is our group activity in group 3 in mathematics in the modern world. What math concept is fully discussed on your assigned video? Tessellation. There are 3 basic shape tessellate: 1 triangle, 2 hexagon, 3 squares, and lastly there are 3 rules: have 1 translation, 2 rotation, 3 glide reflection. What is about this concept? Cite few more real world cases or example that will show the concept. This concept is all about tessellation by M.C. Escher. Inspired tessellation art. For me, my own understanding, the concept of video is about explain the basic principle behind tessellating shape and patterns. It shows a simple visual demonstration of tessellating triangles, hexagon, and square. And also, they explain how they can transform using translation, rotation, and glide reflection to create shape. What are your insight about these mathematical truths or certainties? For me, they say that mathematics is also is so difficult and need to understand, and the truth there are absolute truth in mathematics such that the axioms they are based on remain true. That's all. Thank you. Bye-bye.
Hey everyone, my name is Jeremy Dixon Jr. There are guide questions. First, what is math concept? Is fully discussed on your assigned video. And second, what is about this concept? Cite few more real words cases or example that would show the concept. And third, what are your insight about this mathematical truth or certainties? First concept is tessellation. A tessellation, an arrangement of shapes closely fitted together, especially of polygons in repeated patterns without gaps or overlapping. An tessellation created when a shape is repeated over and over again, covering a plane without any gaps or overlaps. Second is a tiling over a plane with no one or more figures such that the figures fill the plane with no overlaps and no gaps. Example of tessellation are a tile floor, a brick or block wall, a shaker or chessboard, and the fabric pattern. And there are only 3 regulation tessellations. Those made up of square, equilateral, triangle, or regular hexagon. And third, a flat surface refers to the repeated placement of shapes with no overlaps and no gaps. These shapes are also called tiles. In mathematical tessellation can be generalized to higher dimensions and variety of geometries. Thank you.
So good morning, sir. My name is Ben Stewart Istabiola. So today we're going to talk about tessellations. What are tessellations? The word for tessera in Latin means a small stone cube. They were used to make up tessellata, the mosaic picture forming floors and ceilings in Roman buildings. The term has become more specialized and is often used to refer to picture or tiles, mostly in the form of animals and other life forms, which covers the surface of a plane in a symmetrical way without overlapping or leaving gaps. A tessellation is created when a shape is repeated over and over again, covering a plane without any gaps or overlaps. There are 3 regular tessellations, those made up of squares, equilateral, triangles, or regular hexagon. Symmetry. If you look at the completed tessellation, you will see the original motif repeats in the pattern. One mathematical idea that can emphasize true tessellation is symmetry. 4 types of symmetry in a plane. There are 4 ways of moving a motif to another position in this pattern. These were described by Ischier. Translation. It shows the geometric shape in the same alignment as the original. It does not turn or flip. Reflection. It is a shape that has been flipped. Path. Rotation. It is spinning the pattern around a point, rotating it. Glide reflection. It is a reflection and translation are used concurrently, much like the following piece of Ischier-Hausmann. Type of tessellation. Semi-regular tessellation. When 2 or 3 types of polygons share common vertex, then a similar regular tessellation is formed. Demi-regular tessellation. There are 20 different types of demi-regular tessellation. These are tessellation that combine 2 or 3 polygon arrangement. 3. Non-regular tessellation. A non-regular tessellation can be defined as a group of shapes that have the sum of all interior angles equaling 360 degrees. 4. Other types. There are two other types of tessellation, which are non-periodic tessellation and three-dimensional tessellation. Guide question. Number 1. What math concept is fully discussed on your assigned video? The concept that is fully discussed on this video is tessellation, and one of the mathematical idea that can be emphasized through tessellation is symmetry. Number 2. What is about this concept? Cite few more real-world cases or examples that would show the concept. The real-world cases or example of these concepts are water and reflection of mountain in a lake. Wings mass butterflies are identical on the left and right side. Number 3. What are your insight about these mathematical truths or certainties? My insight about this mathematical truth or certainties is a tessellation is created when a shape is repeated over and over again, covering a plane without any gaps or overlaps. When you fit individual tiles together with no gaps or overlaps to fill a flat space like a ceiling, wall, or floor, you have a tiling.
Number 1. What math concept is fully discussed in your assigned video? The discussion is all about tessellation art. Number 2. What is about concept? Cite few real-world cases or examples that would show the concept. Tesselation is a special type of tiling that uses shapes or surface with no gaps or overlaps, and the example in real world are tile, floor, basket, and etc. Number 3. What are your insights about these mathematical truths or certainties? My insights about these mathematical truths or certainties, it helps us how to create a pattern in our daily lives.
Hi, good day. My name is John Lester Pisaday. First year BE Scream, Section Golf. Concentric circles in nature. A set of concentric circles is another typical shape found in nature. These circles are all concentric, meaning they have the same various radii. This indicates that the circles are all various sizes and are stacked on top of each other. Math may appear abstract in times, but it can readily be found in plants that we see every day. Take a familiar walk around your neighborhood and see if you can some of these fundamental mathematical principles in flora. Natural examples of concentric circles can be found. The rings on the inside of a tree's trunk, as well as the ripples created when a pebble is dropped in water, are similar to the rings within an onion. Circles with the same center are known as concentric circles. An analysis in this era between the concentric circles with differing radii. Concentric circles are circles of various sizes that shape are common water. They form a ring of around each other, spreading out and growing larger. They are arranged in pans and tray stamps. They can even be found in your kitchen. Count how many circles you can locate after slicing an onion. Have you ever dropped a pebble in a pan and seen it ripples in circle? On the rings that form a circle, a trump is all. Those are concentric circles. Math is all around you, whether you're hiking, gardening your home, or simply walking around your neighborhood. Not only the architecture of the buildings you see, but also in the physics and chemistry that goes into the construction of streets and walkways. There are 3 guides. What math concept is fully discussed in your assigned video? Tesselation is a subject that is truly addressed in the movie, and symmetry is one of the mathematical ideas that may be stressed using tessellations. Number 2. What is about this concept? Cite a few more real-world cases or examples that would show the concept. This reflection of trees in pure water and reflection of mountains in a lake are real world. Examples of this notion: the left and right sides of most butterflies' wings are identical. Number 3. What are your insights about these mathematical truths or sentences? A tessellation is generated when a shape is repeated again and over again, covering a plane and any gaps and overlaps. According to my understanding of this mathematical truth or sentence, a tiling is created by fitting individual tiles together with gaps or overlaps to fill a flat region, such as a ceiling, wall, or floor. That's all. Thank you.
Hi, good day. My name is Remark Namuel Plirato, BS Criminology, Section Golf. There are 3 guide questions. First, what math concept is fully discussed on your assigned video? Second, what is about this concept? Cite few more real-world cases or examples that would show the concept. Third, what are your insights about this mathematical trust or certainties? First, the video examine about decoration or example and rules on making an example. In math, decoration are renowned type of numerical workmanship. It fits shape together to make a mathematical example or a typical example that has a reasonable turn, scheme, reflection, and interaction. Tesselation is an extravagant word from fitting shape together to that there are no rules between the shape crossover as through your address a jigsaw puzzle, tailing a divider or clearing away. It might appear as though there's not a lot of maths associated with decoration, but rather indeed everything's with regarding to the points. Second, handling through issues can make manageability issues more unmistakable and significant to understudies. Models give substantial application to information and abilities acquired in the homeroom as they identify with understudies themselves and society. Models likewise understudies to know about the decisions they make, the how they fit into a more northward cultural setting. Models show the intricacy and unconventionality of main problems and trashly can animate basic reason. They likewise feature and requirement for a between and multidisciplinary way to that way. Critical thinking further utilizing models from this present reality that in a many case this is no idea answer for a given issue. In any case, in doing as such gets under studies bounding arrangements instead in simple zeroing in issues. The last one, third. Tesselation can be very useful in education. And in teaching mathematical, they can be used from kindergarten to high school. Creating tessellation does not depend largely on numerical skills. Therefore, students do many different level of mathematics. Them have an equal chance to make wonderful artwork and pattern with tessellation. The older the problem solving that is part of creating makes in work the time spent on teaching about them. Seems titillation have patterns made from small sets of tiles. They could be used for different counting activities. Students could count how many tiles are in a certain row, or squares, or group, or triangle. They could count how many of the tiles are colored a certain color, or they could find a group of 8 diamonds or any other specific shape. 2 or more tiles usually make some other shape. So a student could find some tiles that make a square, a large triangle, a hexagon, etc. Students could possibly find how many different shapes they could make with 6 or any number tiles if the shape are not the usual.
What math concept is fully discussed on your assigned video? In my assigned video, I discuss about what is distillation. It is an animational video that explains the principle behind the distillation of shapes and patterns. It also explains how they can transform using the rotation and glide deflection to create another shape. The video presentation shows a very simple visual demonstration of distillating shapes. What is about this concept? Cite few more real-world cases or examples that should show the concept. The concept of the given presentation is explained the pattern of mesmerizing visual effect through repetition of the geometric shape. As a fundamental region is a shape that is repeated in order to form a distillation. It is also called the tile, merge, vertex, and polygon, that most of the time when it derives repeatedly can form distillation. What are your insights about this mathematical truth or certain test? My insight about this mathematical truth is when the pattern in which geometric figures repeated and without any gaps, and it will fit together when it is repeated.
What math concept is fully discussed on your assigned video? The video presentation is all about tessellation art, and the 3 types of tessellation are translation, rotation, blend, reflection. Translation is the shape repeats by moving. Rotation is the shape repeats by rotating. Blend, reflection is the shape repeats by reflecting. And the 3 types of shapes are triangles, hexagon, and square. The second question is, what is about this concept? Cite few more real-world cases or examples that would show the concept. The answer is, it is the process about creating a two-dimensional by using repeated and geometric shapes without gaps and overlapping, just like for example tiles, chessboard, cyclone, and etc. Third question is, what is your insight about these mathematical truths and certainties? My insight about the mathematical truths is that Tesselation is created when the shape repeated over and over again, covering a plane without any gaps. And if you look
At the completed tessellation, you will see that original motif repeats in pattern.
There are 3 guide questions. 1. What math concept is fully discussed in your video? 2. What is about this concept? Cite few more real number, cases, or examples that would show the concept. And last is what are the insights about this mathematical truth or false sentences. 1. The video discuss about tessellations or pattern and rules when making a pattern in math. Tessellations are a famous form of mathematical art. It fits shapes together to create a geometrical pattern or a normal pattern that has a clear rotation, glide, reflection, and translation. Tessellation is a fancy word for fitting shapes together so that there are no gaps between the shapes and none of the shapes overlap. As if you're solving a jigsaw puzzle, tailing a wall, or weaving a path. It may seem like there's not very much math involved in tessellations, but in fact it's all about the angles. For example, the idea of theories is a manual different shapes block falling from above into rectangular space anytime you complete a line all the way across without any gaps. The line disappears and the block above itself down. The second is what is about this concept. Cite few more real number, cases, or example that would show the concept. So, tackling real-world problem can make sustainability issues more tangible and meaningful to students. Real example provide concrete application to knowledge and skills learned in the room or in the classroom as they relate to students themselves and society. Real example also encourage students to be aware of the choices they make and how they fit into a greater societal context. Real-world example demonstrate the complexity and unpredictability of real issue, and as such can be stimulate critical thinking. They also highlight the need for an inter and multidisciplinary approach to problem solving. Further using example from the real world demonstrate that oftentimes there is no perfect solutions to be a given problem, but in doing so, get students thinking about solutions rather than just focusing on problems. The last is what are your insight about this mathematical truth or false sentences. Tessellation in math can be extremely valuable in training and in educating math. They can be utilized from kindergarten to secondary school, making the decoration doesn't rely to great extent upon mathematical abilities. Those the understudies with a wide range of levels of mathematical capacities can make them. All understudies have equivalent opportunity to make superb work of art and examples with decorations. The more established that understudies, the more compounded the fine art sample can be. Simply the critical thinking that is essential from creating the decoration design make it work if times spent on instructing about them. Since tessellations have design produced using little arrangement of tiles would be utilized can various counting exercises. Understudy would include the number of tiles in a specific line or square or lettering or triangle. They would count the number of the tiles and shaded of specific tone, or they would discover gathering of it precious stone or some other determined shapes. With later younger steers, you would have them find out with regards to decorations with designed block bits of mathematical figures such as squared, rhombus, triangles, hexagon, and square shapes. You would make your own example pieces by cutting them out of creased cardboard. Understudies could assemble the shapes with the goal they recover a surface totally. They would take one of the example pieces and follow it can clear piece of paper, then at the point take the shapes and line dependent upon one side of the track edge shapes and follow it one more. That's all.
So hello everyone, my name is Junior Vargas from Section Go, and this is our report from Group 3. So the first question is, what math concept is fully discussed on your assigned video? So the math concept that is discussed in our assigned video is all about tesselation. So all of you must think, what is tesselation all about, right? So a tessellation is created when a shape is repeated over and over again, covering a plane without any gaps or overlaps. Another word for tessellation is tiling. So ang tessellation na kay mahimo kung isa ka shape o isa ka butang is magbalik-balik diya sa iyang pisto na walay mulapas or more overlaps. Okay, ang isa po ka word for tessellation is tiling. So the next question is, what is about this concept? Cite few more real world cases or example that would show the concept. So a tessellation is simply a tiling that has a repeated pattern of one or more shapes. For a pattern to truly be a tessellation, the shapes cannot be overlapped and can have no space between them. So ang tessellation na simple lang, isa siya ka pattern na same lang ang pattern tapos nagdikit-dikit. So ang pattern daw para matinuod nga tessellation, ang iyang shape kay di pwede mag-overlap o wala siya spaces sa ilang pagtapad-tapad. And also, there are some cases or example that would show the concept of tessellation. So the first example of tessellation is called honeycomb. Another place to find tessellation in the real world. So una daw nga example sa tessellation is honeycomb or kanang balay dito sa mabuyog or sa di ba makabantay ka nga yung shape is hexagonal tapos tapad-tapad, so no space. So one siya example sa first example sa tessellation. So the next example of tessellation is the Tauric tessellation, a leaf type pattern of village in Alhambra, Spain. So ang next pattern na sa tessellation is may leaf type dito pattern na makita na siya sa Alhambra, Spain. So here are also the three types of tessellation. So the first is translation. So what is translation? The translation is a tessellation which the shape is related by moving or sliding. Ang translation daw kay isa siya ka tessellation na shape na na-relate siya sa kanang mag-yok or kanang sliding. So the second type of tessellation is what we call rotation. A tessellation which the shapes repeats by rotating or turning. So ang rotation daw kay guys, isa po siya ka tessellation. Yung shape kay nagbalik-balik by rotating or tuyok or turning, so balik. So muna ang guys, rotation. The three types of tessellation guys is what we call reflection. The reflection is a tessellation which the shape repeats by reflecting or flipping. Kung kanto daw guys, reflection is tessellation pero siyang ang iyang shape is same lang nagabalik-balik. Pero ang iyang paagi is reflect or flipping. Reflect. So kabalo mo ano, reflect na kanang sa amin makita na to siya. Kana siya example sa reflect kung kanang flipping kanang dibalik. So guys. So here we are in our third question, guys. So the question is, what are your insights about the mathematical truths or certainties? So my insights about this mathematical truth or certainties are it can be a new addition of designs, whether it will be accepted in the greater of cultures or in spheres of life such as design and arts. So that would be my report in my group. Thank you for listening, guys.
My name is Marcela Beatrix E. Ortega, Section Golf. Tesselation, a shape that repeats to make a pattern. 3 basic: triangles, hexagon, and squares. 3 rules: translation, rotation, and glide reflection. What math concept is fully discussed on your assigned video? Answer: tessellation. Number 2. What this concept about? Tessellation is created when a shape repeats to make a pattern covering shapes, namely triangles, hexagons, and squares, and has 3 rules, which are translation, rotation, and glide reflection. Tessellation can be seen in a variety of mediums, including art, architectures, hobbies, and many other fields. Oriental carpets, quilts, origami, Islamic architecture, and MC Easter's work are just a few examples. Tessellation can be found on Oriental carpets in an indirect way. Number 3. What your insight about mathematical truth of certainties? In tessellations, whenever 2 or more polygons meet at a point or vertex, the internal angle must add up to 360. This continues until infinity. These mathematical truths have many backing because it clearly illustrate and demonstrate how tessellations continue or can go on forever. Thank you.
Hello everyone, I'm Miguel Saulan and my answer for question number 1 is tessellation. What is this about concept? So this concept is about tessellation. So in which tessellation is a shape that repeats to make a pattern. So tessellation is usa siya ka shape, then ginabalik-balik siya para makabuhat ta og pattern. Then it is also a tiling over a plane with no one or more figures, such that the figures fill the plane with no overlaps and no gaps. So tessellation has their 3 types. The first one is translation. So a tessellation in which repeats by moving or sliding. So mo siya ang translation. Then the second one is a rotation. So a rotation also is a shape repeats by rotating or turning. The last one is reflection. So reflection is also a shape repeats by reflecting or flipping. And example of this in a real world case are just like tile floor, the cheese board, the fabric design, or even a graphing paper. So as we notice, in a graphing paper, we can make uh, a pattern repeatedly. I didn't have a deep or a deeper knowledge about math, but for me, what makes me believe in the truth of mathematical is from the statement like 2 plus 2. 2 plus 2 equals 4, because the 4 is defined as 2 twos, and one can be completely certain that 1 plus 1 is 2, because 2 is defined two ones.
Face in your face.